Olá, pessoal. Opa, Augusto, eu posso... Olá, pessoal. Boa noite a todos aí que estão com a gente mais uma vez aqui no nosso canal da Elvin. Mais um tema super relevante sobre SRE. Estou fazendo a intro aqui inicialmente em português, mas a sessão tem uma convidada internacional, que é a Daniela, então a gente vai fazer chavear para inglês já já, e aí, desculpa aí se sair alguma falha, mas acho que todo mundo vai conseguir entender. Então, quem quiser trazer perguntas em português, qualquer coisa que se sinta mais à vontade de falar em português, fica à vontade. A gente, na sessão, vai estar falando em inglês, mas as perguntas a gente vai responder normalmente, tá? Então, super obrigado por vocês estarem com a gente aqui novamente, né? Eu vou chamar nossos convidados ao vivo aqui para a gente começar a conversar. Espero que a sessão seja bem legal para todos. So let's first welcome Daniela Miel from Momento. Hi, thanks a lot for joining our web session. Thanks for the time to share some knowledge and teach us a little bit more about serverless and some other context regarding that. And if you could please introduce yourself so that our audience can get to know you, and then a little bit more about your background.
Of course. Hi, everybody. Thanks, Bruno, for having me. Super excited to join the session with Jamie and Peterson and discuss serverless with everybody today. My serverless career started at AWS on the DynamoDB team. I was an engineer working on the DynamoDB product and, of course, working with various database engines. And DynamoDB effectively has a serverless architecture where you do not manage infrastructure, you just use API calls to interact with the service. After DynamoDB and AWS, I wanted to start somewhere smaller, try my hands on a startup. So I joined a San Francisco startup called Lightstep. They are in the observability space as well, just like Works. We specialize in distributed tracing. When I started there, we were 10 people. Now it's, anywhere, I think above 120 people. I've lost count. I was there for 4 years, and I ended up running their backend platform infrastructure team as a director of engineering. And after 4 years, wanted to go back to serverless and build a caching system. So at Momento, that is what my co-founder Kwaja and I are working on is completing the serverless architecture, the serverless world. Yeah, that's a quick introduction of myself.
Yeah, thanks a lot, Daniela, and we'll get back to serverless and Momento in about a second, so we'll have plenty of opportunity to detail more the challenges and the opportunities that we see on the serverless world, so thanks a lot. And we are also going to have today Jaime Nagase. I'm not so sure about the best way to pronounce his name, so it's better if you could introduce yourself, Jaime, and thanks a lot for joining us for this serverless session as well.
Hey, folks. Thank you, Bruno. Thank you, Daniela. It's a pleasure to be with you right now. And Peterson is coming to join us. Thanks for the invitation. And about me, I'm the position of Business Development Manager right here for Latam. I'm focused on the serverless in AWS, taking care of all marketing in Latam right here, right now, taking care of all products we calling as a compute serverless, Lambda, SNS, SQS, Event Bridge, API Gateway, and so on. So it's a pleasure to be with you right here right now and discuss the future of the serverless, the challenges, the opportunities, and so on. Thank you so much. I hope you enjoy. And please, whatever question, please make it in Portuguese, Spanish, in German, or whatever. We will try to answer in every single language. Thank you so much, guys.
Thanks a lot, Jaime. And finally, Peterson from also the serverless specialist team here in Brazil. Peterson, thanks a lot for joining us as well. And please introduce yourself.
Thank you, Bruno. I'm glad to be here. Hello, everybody. My name is Peterson. I am a senior solution architect here on AWS, focused on serverless services. I'm being at AWS for 3 years, 9 months. I started in AWS as a technical trainer. After that, as a account stay. Now, serverless. So let's talk about serverless.
Oh, that's great. And thanks for everyone who's joining us right now. And if you have any questions at any time of the talk, please feel free to drop in the chat in YouTube. We are following that here, and we'll be happy to answer whatever question you guys might have. So starting the actual content about serverless, I'm going to start with a question to Daniela. Daniela, you worked in the DynamoDB team for a few years, and then a few years later, you found the moment to make serverless developers a little bit similar. Could you describe the pains that motivated you to do that? I mean, what are the pains that you guys see, and actually how you guys approach those pains in order to offer a similar solution for those serverless developers?
Yeah. So the inspiration definitely came from DynamoDB. DynamoDB, for those of you that are familiar, you understand, of course, that it's easy to use. You can use APIs. For those of you that are less familiar, you may be more familiar with the traditional database management model, where you spin up something like a SQL server or a Postgres server, and you have direct access to the machine, and then you are responsible for maintaining that machine and maintaining uptime and availability. As the data grows, you may have to up your instance size, you may have to add more machines to your cluster. So the DynamoDB model is essentially serverless, as in, as a developer, you should worry about your application and what makes your application unique. And most of the time, you do not want to spend too much time on infrastructure. So that is exactly what inspired us to apply the same philosophy to caching at Momento. So while you have things like Dynamo, and outside of AWS, you have things like serverless Mongo. Aurora also has serverless now. That's another AWS service that's SQL-based. Caching, however, is sort of the piece that we found is still very much managed traditionally through infrastructure. And once you have to take on the burden in infrastructure, there's a lot of operational overhead you have to think about. So things like horizontal scaling, sharding, where do you put your data? Online migration. As your data grows, you don't want to suffer from any downtime, but you have to do migration while your system is online. Hotkeys. When a particular object or particular row is very, very popular in your data set, how do you manage hotkeys? All of these at DynamoDB, we had a lot of engineering behind the scenes so that the user does not have to worry. And similarly, we believe that that is something that can be applied to the caching layer as well. And that is sort of the inspiration behind Momento.
Oh, that's great, Danielle. And we will get back to more engineering aspects of Momento and everything regarding serverless. Thanks a lot for sharing your motivation. I do believe it's indeed a pain to have all those serverless components in a given experience, and then some parts of the journey still not in the same mindset. So it's really good to understand that context before we dive into some other aspects. But first, I want to ask Jaime and Peterson, you guys are dealing on a daily basis with companies in Brazil and Latin America as a whole, and you see that companies are struggling with the scarcity of developers. And do you see any increase in serverless adoption by companies with really small teams? I mean, companies that don't have the luxury of have a big engineering team. Do those companies tend to adopt more serverless? Do you see any such pattern, or it does not correlate with what you're seeing?
I can take this one. We are seeing this kind of thing not only today, but I believe it since I started my career. It's a kind of thing that the market is always increasing, always using more IT as much as they can as a market differentiation. So this is a kind of gap. I believe it's not gonna close. And I believe DevOps, Agile, ISC, or Kaizen and other methodologies is helping the developer, and not only the developer, the company as well, to make the life of developer easier, I can say for sure, using a lot of automatized tests, feedbacks, looping, and something like that. And serverless is one more thing in all those pieces to put together and make the companies build, provide more solutions, IT solutions, easily, in a way you can reduce, I can say, incidents, you can reduce time to market when you are delivering a new product. And as Daniela said, you have a lot of things that you need to figure out when you are building a new, not only data strategy, but a whole system. So I believe serverless is filling up some gaps and make not only the architects and developers a simple life during the development life cycle inside of their products. I believe it is a kind of thing that serverless is feeding on in all those environments, like in a life cycle of development and in a whole system. I believe this kind of thing.
Yeah, that's great. And you guys work with several customers in Brazil all the time, and we are going through a strong digitalization of companies. I mean, many companies that have been really traditional regarding technology infrastructure, they're now in the process of modernizing their applications to run in the cloud. What are the most common challenges you find in those companies? I mean, companies who are starting with serverless right now, typically, what kind of pains do they face on a daily basis? I mean, it's merely a lack of culture, maybe technical gaps. I mean, what do you see as the most challenging parts for companies starting to adopt serverless right now?
Wow, that's a really good question. What I can say for now, just 95% of the companies in Latam is using DevOps. So, just 5% is using DevOps in a proper way, and 95% is not using it at all. So we have figured out it's a piece that put together DevOps and serverless. It's just DevOps and SRE. It's just the big challenge as well. But just thinking about serverless, just for this focus, I believe the way that serverless is the first thing that we need to figure out. And they are struggling to know the difference between managed services and the serverless as well. Managed services, you are not handle your own server for sure, but you really know there is a server behind the scenes working for you, like EKS, ECS, or something like that. So you are thinking about a traditional model. When you are changing this way for the serverless operation model, you are not thinking anymore about serverless. You are thinking not anymore about traditional applications. You are thinking about more each requests, each events are passing through your entire system, and you are more worried about the quality of your code and not thinking how the code is running behind the scenes or something like that. These are the first thing that not only in Brazil, not only in Latin America, but in the entire world needs to figure out. It's the first challenge you need to pass through. You need to break this barrier, because it's a kind of thing that you are more comfortable to use it in a first thing. And the second one, I believe, 3 tiers traditional application, you need to move it on to the next phase of modern applications, I can say. It is event-driven architect. So this is another thing that you need to figure out how to put together, how to build event-driven system based on reliability. This is a kind of thing that make your system more reliable, because the events is not changing. Is the part that you are make the SLA, SLO, SLI make more resilient, and all those pieces will be decoupled, and they will be more, how can I say, resilient as well. Because if something goes wrong, if you put a bug inside of your Lambda or your microservices, whatever, it falls down for any reason, your event still be on the broker, so you have time to put it again in a production way, roll back or whatever you have to do, and your persistence of your system will be the same, and other companies will be on running and producing your output, I can say for sure, since they are coming back. So this is a kind of thing that you need to realize it is very different when you are talking about a front end, back ends in a database as well. So you need to think about events. I believe this is the most challenge for the developers and the architects need to figure out how to use the best way of the serverless,
Yeah.
Bruno, may I contribute?
Yeah, sure. Yeah, feel free, Peterson. Yeah, please.
Okay, thank you. So this word, serverless is a characteristic of some AWS services. Those the developer don't need to even know there is an operational system or a server behind the service. And when we talk about serverless adoption, I particularly do not come to the customer to talk about serverless. I come to the customers to talk about event-driven architecture and application modernization. Because when customers understand what is event-driven architecture and what event-driven architecture could do to the business, how to lead with a synced process versus syncs process, and how Lambda, Event Bridge, SQS, SNS, API Gateway, and for example, DynamoDB as an event store or an event source could help to build this kind of architecture. The chat about serverless becomes more meaningful. It's not about using or not using something there's AWS provided as serverless services. It's about what kind of architecture and what kind of problems serverless services can help me most to resolve in a quickly way. Mainly because we have small teams, Linux teams, agile project methodology. We have to create digital products that delight our customers, and the predictability is even more day after day. So if developers don't have time to focus on the application, instead focus on operation systems, doing the right architecturing, using serverless services from AWS that could improve this life cycle of development.
Yeah, I believe for operation teams that they are more used to monitor services and stuff which is running on a given port, a given set of servers. And this asynchronous and event-driven architecture is really different from what they have been doing for maybe 20 years. So I think it's a really huge shift in the way we think about solutions. So it's really something to kind of unlearn before we can learn again, because it's really, it's not something that we can directly translate. You do not simply pick, something you built maybe using virtual machines and everything that was available 10 years from now, and you simply rewrite them to use Lambda. You gotta really think about your architecture again, but then you get a lot of the benefits of asynchronous processing, event-driven architecture. So it's really something unlearn before you can learn again, a whole different model. So it's really
what delights me the most from AWS Lambda ecosystems is not the code inside the Lambda, but the integration layer. How you can pull a queue or pull a Kinesis on an MSK or a DynamoDB strings without do any code. It's codeless. You only put your code inside the Lambda and start to consume the queue, start to consume the string, and after that you can put the information inside Event Bridge or call another API. Those integrations, serverless integrations, for me is the most minimal impact to use AWS serverless services, because those integrations when I was back in the time I was developer, Java developer for many years, those integrations were where I had to spend more time doing code on the integrations, on the consumer queue to put from one side to another side.
Yeah, definitely. I think, moving data, across different systems and everything that can go wrong is, at least I was a Java developer myself. The bulk of my time was dealing with all the trouble that we could find and thinking about how to make those issues the least impact possible in the system. So it's definitely, I connect a lot with what you just mentioned. So that's definitely a really big shift in the mindset, and something that we have some good benefits, but it's not really easy to learn for who have been developing and operating products for many years in a totally different approach. So it's really a big learning curve. And that actually connects with my next question, which is when we listen about companies adjusting their products, modernizing their products to run in the cloud. Often we hear about serverless containers, and some of them simply migrate their virtual machines and try to replatform some of the components. So that approach might vary according to the company, but I think that's definitely a steep learning curve. And you guys, do you have like a list of some stuff that is recommended that you do, and some stuff you recommend companies to avoid? Some good plus versus bad patterns when companies try to approach those servers and containers applications when you modernize. How you guys recommend companies do? Is there a top 10 list of maybe, or top 20 list of stuff that should be avoided and stuff that will provide a good, a smooth learning curve? Is there such a good recommendation way?
Bruno, I have seen teams concerns a lot with, I will put my code on a container or in a Lambda. Even Lambda does have now a container compatibility. So, okay, I can write a Docker and put on Lambda. I can write a Docker and put on EKS, ECS, on top of Kubernetes, whatever. We need to, the customers, my recommendation for customers is to really focus on software engineering. For example, 12-factor methodology, architecture, hexagonal architecture. Best practice of software engineering are not jeopardized. We need to continue to improve our code besides the place that we put our code, inside Lambda, inside a container, because we have seen the customers only seeing the main parts of, okay, a container, okay, it's a Lambda. But when you write a code with the best practices for software engineering, this code could take the most of the infrastructure piece of software that they had from Lambda, from EKS, wherever. So the first recommendation is, remember, software engineering is good practice, unit testing, decouple, best practice for your object or all languages. Those guys are still there. We need to continue to use. And this is, I will stop here. Okay, let to Jaime complete something, and I put some other thoughts as well.
I believe from the of course, from the developer perspective, Peterson covered everything. But if you are talking about strategy for the company, the main thing that I'm thinking is, don't try to build up a real big product to move it on all your infrastructure, all your system to the serverless for the one shot. You need to start small in a single squadron or one team or something like that, and try to experiment as much as you can about serverless, because there is a variety of things that you can use it serverless, not only for all user cases that we can find in the internet, because this is the way that you bring innovation inside of your company. And the second thing, why you don't need to build up a real huge project to move it on all your application is you can frustrate your developers as well, because it's something that is going to be top down. It's not a kind of thing that developers really willing to do in your daily basis. They really to be free to experiment every single piece inside of the cloud or outside or whatever. And the third thing that the companies need to figure out how you can bring value to your company using serverless. These two things that it's mainly important for the companies, and you need to figure out how is your best applications you are building up to make a market differentiator, and those applications will be the best ones to use serverless, because serverless you are bringing time to market, cost optimization, and you will bring a lot of innovation inside of your company. But this must be customer facing, touching, and a market differentiator or something like that that you bring value to your company. And after you build up one real big business value application, you'll be able to spread out the serverless inside of your own organization, you know.
Yeah, that's something interesting. I see that very often when we see good development teams which lack the SRE expertise, or maybe they don't have anyone really specialized in monitoring operations, I see those teams should be like the easiest ones to extract value from serverless architecture. Because if you think, I mean, nowadays we listen about Kubernetes a lot. I mean, it's even, I read recently a Dilbert strip talking about Kubernetes, so it's really widespread. I mean, everyone talks about that. But I think the complexity of everything involved, I mean, a big container cluster and everything, it's not suitable for many teams that lack those engineers that can operate that. So I think many teams that are much better at software development comparing to operations, they would find an easier life, I believe, using serverless architectures instead of trying to move to Kubernetes clusters, because it's really, I mean, it's like something gigantic that some applications they might not extract value at all. So I think some of the cases we see people using containers and Kubernetes, they would be better off simply moving to a serverless architecture first. So that's something to evaluate. But that's really true. I mean, try to avoid that really huge project with a huge complexity and a long time to develop, starting small with something which might not be so mission critical at the beginning, and then as you learn and become more comfortable, you migrate some other workloads. Seems to me like a much better approach that takes off much of the risks involved. So that's really interesting. And it's kind of funny. Peterson was talking about the software development practices. I don't know if it's only my bubble, but I have been listening to a lot of discussions talking about domain-driven design and hexagonal architectures and everything. And it's kind of, sometimes I think we complicate too much some stuff that could be really much more simple. But I think this kind of a little bit more focus and discussion about what are the good software engineering practices, and try to apply that on a daily basis. I mean, continuous delivery, as much tests as we can do. Those are practices that whatever is our software architecture, we are going to be benefited from. I mean, those approaches. So it's really trying to apply, I mean, the really consolidated knowledge to a new kind of software stack. But I think those practices are really validated after all those years. So that's true as well. And Daniela, now I'm gonna try to shift the discussion more towards DynamoDB and everything, which is a really popular component. I started knowing about DynamoDB when I read a NoSQL paper talking about DynamoDB, that NoSQL database that was created to solve the Amazon checkout problem, and now it's much more. I mean, much more than that. I mean, a lot of Amazon, services and other components rely on DynamoDB, so it's really widespread on companies that run in the cloud. And there was this belief that DynamoDB was so efficient that it didn't require any level of caching. You simply store data there and would be really, really convenient and solve all your problems. But you and the Momento team found that DynamoDB and Momento can complement each other really well, adding some caching layer to speed up DynamoDB and also reduce costs could be really interesting. So if you could dig in a little bit further on this use case, I mean, how you can use DynamoDB and a serverless cache and like Momento together to improve your architecture, that would be really good for us to start from there and then talk about some other subjects.
Sure. Yeah, so Dynamo's great. Even though I no longer work there, still proud to have been an engineer on the team. And AWS has great products. So we actually work with a lot of DynamoDB customers. DynamoDB also gives you very strong durability and availability guarantees, right? So for a lot of use cases, that may be sufficient. For some use cases, it may be overkill, meaning that as long as you have your data in Dynamo, it does not lose your data. It has durability guarantee. But sometimes you need your data in sort of a more transient state. And it's okay if it's, eventually consistent, if it's a little bit behind. That is the exact use case for caching. And actually, the I think number one or one of the most popular reasons is cost. So DynamoDB does get expensive. Of course, they have to put in a lot of very complex architecture and a lot of engineering effort to keep your data highly available. And it comes with associated costs, especially for smaller objects, because Dynamo will charge in increments of kilobytes, actually 4 kilobytes to be exact. So if you have a lot of small objects, each of them get charged as a 4 kilobyte object anyway. In this case, we find caching to be complementary if you use it as a layer in front of DynamoDB to cache the objects that are frequently accessed. So that's sort of a major, because of the serverless model, we are, pay as you go, simple pricing, you only pay for what you use out of Momento. We found cost to be a big factor for why people go to caching, and then they don't have to pay for provision throughput on DynamoDB. Another reason here is that there are some sort of hard limits on hotkeys and at the DynamoDB per key or per partition. If you're getting really deep into the weeds here, meaning what? Meaning that if you have a really popular object that you want to read over and over again, so for instance, for a social network, you might have a really popular post that a lot of people are viewing. For a game, you might have a really popular game session or a tournament, right, where a lot of people are checking the leaderboard. So that would be a really popular use case where you can cache it, because if you're sort of going to DynamoDB and constantly either writing, like updating something, or reading from it, there is a hard limit to how much you can perform, how many operations you can perform per second on a single DynamoDB row. So that, is where it helps with not just cost, but also performance and availability by putting a caching layer in front. And that's sort of what we've worked with a lot of customers on. In fact, today, customers, a lot of them choose to put Elastic Cache in front of DynamoDB, which is a very reasonable, and I think in many cases it works. However, as this whole theme of this whole talk is around serverless, Elastic Cache still requires you to provision an EC2 instance and then to think about how many instances you need, what instance type you need. So again, it starts to go down this path of infrastructure. And with all the smart engineers that I'm sure your companies have, there is usually, things that's closer to the business and the, revenue, whatever helps your business. And then the less time you spend on infrastructure, the more time you can spend on your actual business and your project. So that's kind of where Momento has come in.
Yeah, that's nice. Actually, you mentioned something that I was about to ask a few questions later, which is, I mean, I have been following the serverless evolution, all those services being offered in a way that you don't need to manage anything, but we still have at least a couple services which come from the serverful moment. Let's say, think about that. I mean, the serverful era, which is like the RDS, which I mean we probably don't have a way. Of course, you can adopt Aurora Serverless, which is a different way of consuming the same solution. So that's a good movement in that direction. But Elasticache, like you mentioned, you still have a component. The first time I used a Memcached was like in 2006. I mean, it was a long time ago. And then Redis maybe 2008, 2009. I don't remember exactly. And I use really before I started working with the cloud, and we still need to manage some aspects which are not really as adjusted to the serverless approach. So we have some infinitely scalable services like Lambda and Gateway and API Gateway and all those components which can scale, I mean, as much as you can. But then you are stuck with some components like Redis, for instance, where you still need to manage some sizing problems and number of connections and timeouts and everything, which kind of does not deliver the serverless promise fully. At least there's this component. So can you talk a little bit more? I mean, you work with Elasticache and Redis for a long time. What are the kinds of most common problems that companies face when they start to manage Redis clusters? I mean, what kind of pains and outages they find when they cannot manage a Redis cluster properly, and how you guys approach that differently, providing a full serverless cache approach?
Yeah, sure. I'll go back to the themes I've already mentioned because they're consistent. So the first one is cost, right? So how does cost come about? It usually comes about when you pick an instance. So when you want a caching cluster on Elasticache, whether you want to use Redis or Memcache, it will ask you, what instance type do you want? From our experience, the bursty, the T instances, right, the ones that are, they're not really good for caching because they have unpredictable CPU and network, and well, everything about the machine is made for bursty traffic, right? So you cannot predict performance on those instances. So at a minimum, I think most people go to like an R or maybe an M type instance, which is a little more reliable and memory optimized, which makes sense for in-memory caching. At the very minimum, you start with one instance, and that has a the minimum cost monthly, because you have to pay for that instance being up all the time, 24/7 for months at a time, months and weeks at a time, even when you're not using it, right? So one of the things we find is that with most of these provision instances, we've barely been able to find any customers that have an instance higher than 10% CPU utilization on average, right? Meaning that for the times that you're not needing the cache, you have to continue to pay for this instance. And that is a bare minimum, is one single instance that is not a T instance. Very quickly, with any serious application, you will want things like replication. So you want at least a replica, like a backup, right? So that you don't have a single point of failure. That's kind of, I think, a pretty basic requirement. So you've doubled your cost. And then from there, very common, you will find that you will need multiple instances. So then the cost and then the more instances you need, let's say there's, I'll go back to my gaming example. Let's say there's some kind of a tournament or a popular event that you want to make sure that your cache is available for. And you need, 4 instances for that event. After the event is over, the data still is inside the cache. So, oftentimes people will be too scared or feel like, they don't want to have to keep scaling up and down for the next event, right? So now instead of paying for one instance, you're paying for 4 instances all the time, just in case you need it for popular events. Other times it's for other reasons, like people find it just like too much work to have to manually scale it. And then you have to, you can look into options like auto scaling. But then what do you auto scale on, right? How do you teach the machines to be smart enough? So it becomes a whole project. You can see where I'm going, where, it's no longer about the game, which is the actual business is about, some machines and sharding and replication. And, it becomes a whole SRE teams project. So that's number one. The second thing I want to talk about is actually the client. So oftentimes when you provide a service like Elasticache, and I don't think there's anything they're doing wrong, by the way, they're giving you the machine. It's up to the user to set up their machine in the way that they want. But for a service like Momento, we have to think about the end-to-end experience. And the experience does not end at just the service. So when I was working on Dynamo, we spent a lot of time working on Dynamo SDKs and the client-side library because that's how the users use us, right? You can't just say, oh, here's my service, good luck using us. We have to make it easy for the APIs and for the user to use the serverless service. So we own our clients as well. So for Memcache and Redis, you're kind of, up to you what you want to use. You can write your own. Oftentimes people don't have time to write their own, so they'll Google and they'll come across some open source client library that communicates with either Memcache or Redis, depending on which one you're using. And you have to find it in the language of your choice, right? So, and then you usually pick the most popular GitHub project, and that's the client you use. The problem with that is that, it's open source community is great, but oftentimes people have very different requirements and they have very different use cases. So it's kind of up to the user and the customer to figure out and test. And a lot of the time do like a separate, again, another project on performance benchmarking, load testing to find the set of configurations that work for their use case. And sometimes it doesn't exist in the existing client. Then what do you have to do? You have to go and modify the client yourself to add, configurations that work for your use case. So the second thing that we're taking a drastically different approach on is that we handcraft and hand tune all of our clients. Right now we have them available in 6 different languages, but more to come in the future. But we have things like the popular ones: Java, JavaScript, Python, .NET. We have Rust and Go. Those are sort of the more trendy ones, I think, with developers nowadays. But for each of them, we do our own load testing. We do our own tuning to make sure that they have reasonable defaults. And then we do the documentation and the additional testing to make it very clear to the end user, here's how you can tune it based on your workload. And that's just something that we've been looking at. For serverless specifically, I'll mention a recent example. Lambdas, right? The startup time, the runtime startup time really matters. So something that for our clients that we are continuing to look into is how to optimize that like initial startup connection time, like how to think about that, right? The warm-up time. And again, it's just something that I think when you're offering a serverful service like Elasticache, it's sort of up to the user, like use whatever client you want. It's sort of, you're on your own when it comes to Googling the best solution. So yeah, I think I'll stop there. Those I think are the 2 most prominent pain points. And I've sort of skipped over all of infrastructure management. I think that's not specific to caching. Like with any infrastructure, you kind of get like sucked into this black hole of infrastructure management and work. And I think that's just sort of a given when it comes to advantage of a serverless system. But I talked about the 2 that I think are more specific to Redis and Memcache and Elasticache.
Yeah, that's true. I mean, when we adopt any NoSQL database, we need to understand really well what kind of problem that solution was designed for. And I think, at least in my former experience managing cloud environments and everything, I saw that many people started using Redis because maybe there was a Ruby on Rails gem that connected with Sidekick. And people didn't really choose, but they picked what was readily available. And Then some people started using Memcached or even Redis to web session store, and they found some nice library that would simply serialize their sessions through the network, and that would work. But then you start to using that component in your production stack without really understanding really well how to manage and optimize that. And then we might have some issues, because we may find that the DBA guy that we had that was really experienced in optimizing MySQL or Postgres queries, he does not understand Redis and does not understand Memcached, and then we start having some issues and maybe pay more for the infrastructure than we could. And this kind of, we back at Rivendell, which was my former company, a managed services company that supported environments in AWS. We supported many companies that were e-commerce, and a lot of companies that took part in the Black Fridays events. That was really often, people would scale up some of their clusters, like web session, Elasticache, and everything. And instead of the outscaling groups they had with virtual machines, the caching services would not scale down. It was really often that this kind of behavior you described happened. We saw that people simply didn't want to change anything that was, they're working, and they didn't really have those caching services as one of maybe the cloud build villains. They had that problem totally under the radar. So I think when we kind of focus a little bit more on FinOps and cost optimizations, then we start to see some good opportunities of reducing how much we spend on caching, or maybe how a different caching approach could bring benefits to us. So that's really interesting when we look, how we can reduce our cloud bills. It's kind of funny because Amazon offers a lot of services to help you optimize your bills. There's I forgot the trusted advisor and all those services. Peterson and Jamie definitely know more about those services than I do. And actually, that connects with my next question, which is, we are now in a moment in the economy in a really hard downturn. A lot of companies are struggling to survive. Every company needs to reduce their costs right now. Is there something that we can do in a good approach to analyze and understand better how we are spending in our cloud accounts, and especially for serverless stacks? Many people don't have any experience measuring that. It's different when you were managing virtual machines. You have the CPU, you have the memory, you have those kind of static metrics to follow. In serverless stacks, I think people are really clueless about how they can start to understand a little bit more about their cloud costs and optimize. Could you bring some tips or recommendations for companies willing to understand more about their serverless stack? There are a lot of services which are paid for on demand. It's based on the number of bytes scanned or the number of invocations. There are plenty of different ways to be charged for the serverless stacks. How you guys recommend companies start approaching to better understand and then optimize their cloud bills regarding those serverless components?
Great. Let me ask you something, Bruno. Can I answer the questions in Portuguese over there in the chat, or?
Yeah. Actually, if we can
But
definitely
there is
pause.
a match between your question and then.
Yeah, feel free. We can
Portuguese,
pause.
it's okay. It's okay.
Yeah, I think it's. We can pause for a brief moment and answer. I think it's better that people understand what we are saying. That try to stick to English only.
Thanks,
So
Daniel.
that's okay.
Rafael, sobre a pergunta, né, se é uma melhor iniciativa usar serverless. Uma coisa que eu posso te confirmar, a grande maioria das startups que estão começando utilizam serverless desde o começo, assim, né? E uma segunda, quando a empresa não tem tanto conhecimento de TI, acho que esse é o conceito da pergunta aqui, serverless ele te tira um fardo de gerenciar servidores, né? Então, na verdade, ele te deixa até mais leve, onde você tem um time mais enxuto de trabalhar dessa forma, tá bom? Então, cara, faz muito match com novos workloads, com esse tipo de coisa. Na verdade, faz muito mais match com startup e com com a entrega de novos workloads, tá? E aí, se o Peterson quiser incrementar alguma outra coisa. E aí, o Rafael falou sobre a calculadora, né? Acho que foi o Rafael. Bom, não, foi o Cristiano. Serverless, ele é mais barato, não importa o que aconteça. A gente vai tentar nessa explicação também aqui junto com o Bruno em inglês, tá? Porque você só paga por aquilo que você usa. Se você vender muito, você consome muito. Se você vende pouco, você consome pouco. Então, é como se fosse uma conta de você paga por aquilo que você usa, sem contar os free tiers, que você tem 1 milhão de execuções, por exemplo, em Lambda, que são de graça todo mês, tá? Não é uma coisa que você usa e depois acaba. Então, dá para você criar uma startup, se você não usar aquele 1 milhão, você pode até desmanchar a startup, você não vai ter gasto nenhum ali dentro da AWS. Então, eu acho que tem muita coisa ali que dá para ajudar, e serverless é comprovadamente muito mais barato, tá? Então, é um match perfeito ali quando a gente fala, tá bom? Mudando agora um pouco let me switch to English. Daniel, I'm just explaining that the serverless is the perfect match for startups to build up a company, because they don't have the burden to take care of the servers and something like that. You know, this is the summary I can say for sure right here. So once we are talking about a downturn of the economy right now, I believe the serverless is the most thing that I really like is the cost optimization of the serverless, because you need to pay for your consuming inside of the serverless. What I'm trying to say is, if you have 100 requests, you will pay just for those 100 requests. If you are talking about the traditional application, you probably will build up a bunch of serverless, a bunch of servers from the front, from the back, and the databases. And if your business case is not good enough, you just pay for idle time that is providing for your entire solution. And this is a kind of thing that it's not really good for the business perspective. Serverless is allowing right now the fail fast. This is a kind of thing that I really like, because if your business case is not good enough, and you probably will not spend a lot of money, build up a huge infrastructure to provide that solution. And this is a kind of thing that's it's very good. The second question is how we can use serverless to optimize cloud bills. So if you have a lot of scripts, if you have you are building up something of like IOPS or something like that, you know, or if you need to build up some data processing between database or something like that, it's very good to have a Lambda to do this for you, or a FAS, whatever. But it will be simple you to build up a script, put inside your Lambda, your function as a service, and this will be automatically, and you are not going to pay for the 1 million requests inside of AWS. The other clouds, I cannot say anything, but for AWS, I can say for sure, every single month you will have 1 million of requests for free. So this is the kind of thing that I would like to introduce for the first one. And the second one, using messaging as SSKS, SNS, and Event Bridge. I believe millions of events will be cost $10 or something like that during your month. So you need to build up your all infrastructure over this kind of infrastructure, and these will reduce your costs, mainly because you just pay what you are requesting inside of those services. Peterson, do you have something to comment?
Yeah, two cents. We cannot improve what we cannot measure. So to be able to better costs on AWS, we need to be able to build more mechanisms to trace where the costs are. In AWS accounts, we can do this with AWS tags and AWS organizations, AWS Control Tower, to embrace a FinOps mindset. A a shift left on FinOps as well for the development. So shift left on security, shift left of costs, because serverless Lambda is not a silver bullet. Serverless Lambda, there will not be the cheaper solution for everything that you build on AWS. For spikes and unpredicted and non-predicted workloads, serverless, you should do fine. But for traditional 24/7 heavy processors, heavy processors, 24/7, that's 3, 5, 6 days per year. The cost will be less for EC2 instances with saving plans. And you can use Spot as well. You can use Graviton as well. So use the right solution, the right services, and have visibility of the costs, shift left on the cost to, in the first time on developer, from the simple architecture with the best software engineering practice in the first moments of development, is starting to thinking, this is the service from AWS that's helping the most for my no requisite functionalities and requisite functionalities. Yes, it does. And this is the more secured one. This is the cost-effective choice as well, because we need big cost-effective, because our business, our customers need to have access to our services from the customers that fit on their pockets. So how much we spend on cloud is very important.
Yeah, that's really interesting. And something which is not so easy part of the time is nowadays we might have maybe 40 or 50 popular NoSQL databases, and sometimes you're like in the kind of a frontier of what's the ideal data storage for my kind of data. Sometimes it's not so obvious which one you choose, and some of them it might be hard to predict. I mean, I work with AWS since 2009, so it's been quite a journey. And in our solution, in our platform at Elvin Works, we did a POC with Amazon TimeStream, which is a time series database, which, since we do some monitoring for our clients, I mean, that makes a lot of sense for us to try. We estimated how we would be spending on that service, and we were wrong by 30 times. I mean, I have my years of using the AWS calculator pretty much every day. So it's some units. I mean, how many bytes are going to be scanned? There's some stuff you cannot really measure. I mean, without a real workload. So in our case, it was good because we put that workload in a staging environment. We started getting some data. We put that into production. I mean, in a pre-production environment without any customer accessing that. And then with actual data and everything plugged in, we saw that, I mean, instead of maybe $5 to $10 a day, which we expected would be our cost, it was like 30 times more than that. And then, I mean, we stopped the match right there. I mean, no, that's not going to work in a cost efficient way. So we needed to migrate to another data store, still on managed by AWS, but we needed to model in a different approach our workload, because it was not something that we had chosen. I mean, in terms of performance, TimeStream was great, but for our kind of data and everything connected, it was simply too expensive, and we needed to change the approach. So just like Cristiano mentioned, which is kind of a funny comment, sometimes the architecture is decided by the AWS calculator. When we try to mix the components and see how they're going to perform in terms of performance and costs, and then we choose with cost being one of the key decision factors. It's impossible to do, I mean, different than that. Currently, it's really important to take costs into account really in the beginning. So it's really important right now. Let me see my next question. Just a second, because we had some session questions from the audience. I'm kind of trying to see what we have already covered here. So, okay. And Yeah, we talked about the not really serverless characteristic, the Elasticache. So Daniel already talked about that. And there's also some question now for Daniela regarding the success stories of Momento helping companies reducing their cloud bills by replacing Elasticache, specifically in terms of the Redis clusters, and also putting a caching layer in front of several popular AWS services like S3, which pretty much everyone right now is using S3. It was the first service that I myself used in 2009. So, I mean, it's been live in production for quite a long time. So it's kind of often that companies use Momento in front of services like S3, DynamoDB, and Lambda. Could you provide some examples? I mean, what are typical architectures, typical setups in which you guys stand in front of several AWS services and the kind of benefits Momento provides? It would be really good for you to comment a little bit more about that, and then we move on to the other questions.
Yeah. So we talked a bunch about, I think, Elasticache and DynamoDB. I'll just give a really quick review. So for Elasticache, it's about paying for your machines even though you're not using them, and you have to pay and provision and capacity plan for your peak, right? So I talked about the minimum one instance case. Oftentimes you need multiple instances, and once you go up to multiple instances, you do not want to scale down, because it's a whole operation. It's a lot of work, and there's project. Plus, you have to scale up again for your next event. So if you have anything where there's like usually most applications have have unpredictable peaks and bursts, and you have to provision for the highest, right? So if the maximum you ever need is 10 instances, you have to pay for 10 instances all the time. So you can think about the pay-as-you-go model. If folks are familiar with Lambda, that's sort of like the model that saves money for instance provisioning on Elasticache, Redis, or Memcache. For Dynamo, we talked about mostly it's a very nice database service, so it's expensive. Writes and reads are both expensive, especially if you're accessing or updating data a lot. That's where it becomes expensive. And then I also talked about the sort of the object size, right? It's a database. They assume that you're storing objects of kilobytes in size. And at the end of the day, if you have lots of small objects, the cost quickly adds up. So by adding caching, that's where we can save people money. I also talked about the hotkey case. If you have a very popular object that gets accessed again and again, you want to access it more quickly and more cheaply. So that's where caching can come in. S3 is an interesting one. We haven't talked about that one as much, so I'll just mention the S3 use case. S3 is great because you can use it as an HTTP server. We also support HTTP, by the way, so object store. And if you look at S3, their durability guarantees, they measure it on the order of years, right? So like you can expect to keep that data in S3 forever. It will not lose it. You probably forget about the data before S3 will lose your data, right? So they calculate the durability of your data on the order of years. Usually that's too much for applications that are developing nowadays. Again, going back to my gaming use case or my social network use case, a lot of our customers work with applications where like older data do not matter. They really care about fresh real-time data, which is actually a perfect caching use case. And so the fact that your data from a year ago gets the same durability and same performance as the data you're generating today at this moment just does not make sense, right? So with S3, a lot of our customers, what we found is that they start using it like an HTTP server, and the cost of storage is very, very low on S3 because that's what it's made for. It's a file system storage service. What it's not really priced correctly for is the actual server itself, where you're making a lot of requests to it. So you might be reading it or uploading to it a lot. And the operations, you're paying per operation. That cost can add up very quickly as well. So for us, we're an object store. We're faster, but we're a cache, right? So we keep your data for days and weeks, not years. but most of our customers don't need their data for that long. When they need the data for that long, they can always archive it on S3. And in the short time period, like for social network, for instance, my post today, like you and my LinkedIn post, Bruno, today will get so many views in the next 7 days. And then after 7 days, it probably won't get many views or updates or comments, right? So for that reason, as the data becomes more stale, you should move it outside of the cache into something else. But while the data is fresh, you want it somewhere faster, cheaper, and can serve your request. So that's sort of been where we've been able to save customers a lot of money, even compared to a system like S3. And then, essentially working with Lambda customers, the reason they're on Lambda is because they're short on engineers. They don't want to have infrastructure engineers. They don't want to have a dedicated SRE team. So we've just worked really well with Lambda customers because usually caching is the missing piece for them, where they don't want to manage their infrastructure or their Elasticache cluster or their own Redis cluster anymore. And they can just point all their API calls at Momento and be done with it.
Yeah, that's great. That's really nice. I mean, it's really nice to think of the ways we can improve performance and also costs, even for services that we perceive as cheap. I mean, being able to optimize that is really welcome. So it's really good to have some hints on how to do that properly. So that's great. Thanks for explaining that, Daniela. And my final question regarding, I mean, the trenches itself, I mean, the stuff that we are talking about engineering is, I mean, we talk a lot about observability right now. I mean, the AWS Summit that we happened to have last month here in São Paulo was one of the key subjects was data and observability. So it's something everyone is concerned about right now. How you guys recommend that teams designing or operating serverless applications in production, how should they instrument and prepare their applications to be properly monitored and operated? I mean, regarding observability, what are the key recommendations for companies running serverless stacks in production?
For observability, we have the observability triangle. So logs, metrics, and traceability. Starting from logs, developers, need to put the right size of amount of logs and the right structure of logs. Whatever they place the application, from Lambda, containers, good logs meaningful, key value pairs for logs. From the logs, we can take metrics from infrastructure service. For example, AWS Lambda, DynamoDB, and Event Bridge, API gateways, all those services has metrics. Metrics for concurrency executions, metrics for code starts for Lambda. We can take this from CloudWatch synthetics. Metrics for throttle. And in the bottom of the triangle, we have traceability. So we can take some of these logs that our application form functional requisite, for example, number of the bucks inside the bucks or any item inside of shopping cart. I can build a metric from the log and build this kind of metric because we know that the metric that means the most are the metrics that are correlated with the business. Not only the metric about Lambda is down, Lambda is up, Lambda proposes concurrency, Lambda throttle, but quantity of sales, shopping cart, business metrics. This is the metric and logs talking to each other. From traceability, AWS has AWS X-Ray, former serverless lens, to increase this map. We can saw in the service map each page that our service microservices goes. For example, I click on the page and the page is broken. How can I do the troubleshoot? How can I do the troubleshoot? I'm starting with the service map, with the observability, to saw where is the microservices that have a lot of errors. From this map, I click on the microservices and I started to see the metrics to go to the logs. So this is the kind of the concerns that we have to had shift left as well, shift left of observability from the first moment of development, which is the metrics with the logs, with the traceability that our application needs to have to be ready to production. Which metrics is available to wake up my team 2 a.m. if necessary. We had set the right alarms for do that. That is my from synthesizing the observability ready to production. But if I could, I can talk a lot night, yeah, and after I read about this.
Yeah, sure. That's good. And if you guys want to add something, feel free. I'm just gonna pick one of the questions from the chat, which is really good. Rafael asked about the logs in a serverless stack. Do they go directly to the S3, or you leave them stored on CloudWatch, let's say? I mean, in terms of where the logs are actually stored for the time being they need to be stored. Typically, what do you guys recommend regarding those serverless logs?
CloudWatch, when you up a Lambda and you put some logs, they go to the log group inside the CloudWatch logs. And CloudWatch logs is a great place to start. But the company should, maybe they have another source of truth for observability, and customers can move their log from another's partners, SaaS providers for observability, for example, Elasticsearch with Kibana. CloudWatch support this kind of things. But to start using serverless, CloudWatch, and not only for the start, for advanced customers as well. I meet several customers that use CloudWatch, only CloudWatch, to monitor serverless or no serverless services. So CloudWatch logs, CloudWatch is the main point of all AWS for metrics and logs.
Yeah, that's great. Thanks, Peterson, for answering that.
Peterson, there is just one question right here about the location of the logs and something like that. I believe it's the last question.
No, yeah, but that's the one that I just asked Peterson, where the actual storage of the logs. So that's great. Yeah, thanks. And I mean, Daniela, you have worked, I mean, for a few years in an observability company, specifically focused on tracing. So I mean, if you want to compliment, I mean, feel free. I mean, you have much more experience regarding observability than myself, I believe.
Yeah, I think tracing is basically structured logs. You know, CloudWatch is great. CloudWatch Insights is really amazing. I think removes a lot of the people's initial need to want to export it into Splunk or, you know, Kibana to visualize it. But the problem with logs a lot of the time is that it's so easy to generate logs that developers sometimes go crazy and they generate too many logs, and then it becomes harder to actually analyze it. So to me, tracing really just puts logs into structures of like, here's the workflow, like here's one unit of work, here's a second unit of work, and it tries to kind of string it together. It's still relatively new, I think, as a new developer. If you're just learning how to build an application, printing out logs is really the easiest way to reason about. And I think it's a great way to start. When you move into production, I do encourage everybody to at least read more about tracing and about how you can structure your log in the context of a request in your system, so that it's more naturally structured. And the more you structure it, it'll prevent some of the natural explosion of logs in production where you just have logs everywhere, because it'll be because you're putting in a little bit more effort organizing it while you're coding. Later on, it'll be more cost effective. It'll be easier to analyze as well because you have the context. Because a lot of the time when log explodes, it's like, where is this coming from? Like, you know, when did this get printed? And you're kind of trying to string together the picture of your service in your head later. So yeah, I'm not going to say that I think it's complementary. I think people should start with logs. It's very intuitive. but learn a little bit more about tracing. Think a little bit more about it. Read up on it. There's a lot of different products now. Almost every observability tool now supports application monitoring. So yeah, I do encourage people to really consider it.
Yeah, I remember starting to hear about tracing maybe 2018. I don't remember exactly. It was by the time that X-Ray was still in preview mode. It was not GA yet. And a few, I don't remember exactly, but I got to know about Jaeger from Uber, and then I had those as the two most popular options. And now, of course, the APM solution started adding some components. Side, and the open telemetry and open tracing projects became really interesting. So there are several options for tracing right now. So it's indeed really interesting. I'm gonna pick one last question that you guys could answer, each one with your own recommendations, which is, for people, software developers or even infrastructure engineers trying to learn a little bit more about serverless and how they can use serverless stacks as a way to thrive in their careers and to get good opportunities. What do you guys would recommend for people starting to learn more about serverless, how they can maybe have a good roadmap for studies and practicing with serverless components? What you guys could recommend based on the people you saw that have been working in a great way with serverless components? Could you provide some recommendations or tips for people willing to improve their serverless skills and use that as an advantage in their careers?
Jamie, do you want to pick this one or should I?
Go first.
Yeah, I'll go first. So I was a technical trainer on AWS. So we have a lot of we have a lot of cool stuff for those that want to shape their X inside AWS. Bruno, I put a link inside our private chat. Yes, there is a private chat.
Oh, great.
And how can we share with the audience?
Yeah, I'm gonna put in the comments here, and afterwards we can fix that in the description of the video. So all the recommended links we have, we are gonna share several ones. Feel free any links. I put that, it's already in the chat, public chat for everyone, but we're gonna fix that into the video description later. So any other links you might have afterwards, we can go back to the video and pick them again. So it's perfect. But I already sent the link there.
Okay, this link has a PDF, is a serverless ramp-up guide from hero. And there is a lot of courses, a lot of white papers, and this does not change the necessity to get your hands dirty. Start with AWS console, raise a Lambda, launch some SQS, do some tests. For AWS, we have free tiers for those services. Be careful with the free tiers. Go to CloudWatch, put an alarm to do not be charged if you don't want it. And Bruno, and in the synthetic way, I think this PDF, there is a journal, links from AWS skill builders. I think that on the material there has enough to start to learn serverless AWS, and more important, you can start serverless, because serverless, one from the outside, this technology is the means. It's not about serverless, it's about solutions, the right solutions for Daniela, from Momento, the right solutions for the right tasks to delight our customers, to innovate faster, to deliver more content, more digital products for our customers. It's about that, and serverless could help to achieve this.
Yeah, that's great. I didn't know that link, so it was really useful to have that. I share that with our audience here, and I'll fix that to the description. It's really useful. So thanks a lot, Peterson. And Daniela and Jaime, if you want to compliment, feel free.
Just adding just one thing, try on. test it. Whatever you think it's okay or not, just try on to build up your own workloads and try to test it, because it's not gonna cost, I believe, anything to you as a person, because it's you have a free tier and you can do it by yourself. But try on in your company or whatever. But just try on. This is a kind of thing that you gonna learn everything that you touch. This kind of components, and you make more comfortable to use in your daily basis. It is very useful for IT operations, I can say. If you have a script inside of your pocket, and that you're gonna use it. Uh, Sometimes it's gonna be okay to be in Lambda and try on to use an event to start your own Lambda to make this happen. It's gonna be some toil that you are gonna clean up. You know, this is very good.
Yeah, that's great. Yeah, thanks, Jeremy.
I'll just say something really short. Serverless is still relatively new to the world. I mean, I know we are all, experts, and all of you are here because you're interested in this subject. But in the grand scheme of the global technology world, not everybody knows about it. So, we need each one of you to be an advocate, right? At least like when you start a new project, when you join a new company, if you notice there's a lot of infrastructure, like at least ask the question, right? Like, have you considered serverless? Do you know about serverless, right? So spread the knowledge, spread the resources, because it has real value in certain places, and we just want more people to know about it and to be chatting about it. We want the community to grow around it. So yeah, ask questions.
Yeah, that's great. And I shared the Momento website here in the link as well. And if you could talk a little bit more about how people can create an account, I mean, and regarding a free tier or maybe a free trial, how does that work for people willing to try Momento and maybe replace some existing solutions which could be more expensive and not so fast? I mean, how people can start testing Momento and then try in their applications to see if it speeds up and also if it reduces cost.
Yeah, really good timing. We just launched our free tier today, actually. Like as we speak, we launched it in the background. So, we have a very generous free tier. 50 gigabytes is completely free every month. So that should cover most of, if you're just starting out, testing out, that really, we want to be able to cover we want people to be able to run hobby projects for free forever, off of Momento. Effectively, you can use our CLI, you can download it onto your, Linux, Windows, Mac machine, or you can start writing code, whether it's JavaScript or Python or some, fancier language. You can start writing code, and essentially it's 2 to 3 API calls depending on what you want to do, right? The first API call is create a Momento cache. You have to pick a cache name. That is it. So you say Momento create cache, my cache. Well, that's the first API call. And then you can make, 1 or 2 API calls depending on whether you want to read the value back. Second API call, set, right? Set some object into the Momento cache. So write to the cache. Third API call, you can get it back. That's it. So if you're writing any application, you're considering having a data store, we let you sort of configure how long you want it, how big your object is, things like that. But if you want to just get started and try it out, I guarantee you in a few minutes, you can get the Momento application up and running. And we have lots of examples in our GitHub as well. So yeah, thanks for sharing the link, Bruno. That's really good.
Yeah, even being a little bit rusty, I mean, I don't program for quite a while. When I tested Momento with my Java skills, I mean, which are still there, I mean, they might be sleeping, but they're still there. I was able to configure Momento and try it in Java in under 5 minutes. So if I can do it, I mean, over 5 years not programming at all, probably most developers who try it will find it really easy. So it's really recommended. So thanks a lot, guys, for having this webinar with us. I mean, it was really good to understand a little bit more about the serverless components and everything. I really appreciated the time that we spent here, and I could learn a little bit more. I'm gonna also thanks all of your audience for being with us today. And I can open you guys if you want to say some last words for people who have been watching us. Feel free. It's been a pleasure to be with you guys today.
Thank you, guys. I love free cheer.
We do too. Thank you so much. Nice to meet everyone.
Bye-bye. I'm glad.
Thanks, guys.
Glad to be here. Bye-bye.
Bye-bye.